Okay, so today's November 22nd, 2011. We're on lesson 6.1. We're going to be solving quadratic equations by factoring. So there's our objective. Major formulas you guys need to know are standard form and factored form. There's a possibility we'll use vertex, but essentially we're going to be going from standard to factored form. And we're going to go over the types of factoring. We're going to do types of factoring. Factoring by product, decomposition, or algebra tiles. Whatever you feel more comfortable with, you can use. Okay. So the very first question, these are word problems. It says the flight path of a toy rocket is modeled by this function. So the function is y equals negative x squared plus 5x plus 84. Okay? Now, what we need to be doing is we need to be solving. They want to know when the rocket will land and hit the ground. Okay? So in other words, we could quickly take a look at this. What form is this in right now to start? That's right. This is in standard form to start. So we have our A value, our B value, and our C value. What is our A value in this equation? If A is -1, which way will our parabola open? Downwards. Is that right? We're going to have a parabola that's opening downwards. Okay? So, that means we'll have some parabola. Oh, sorry. We have a function. It'll probably look something like this. It'll have taken off from some point, the toy rocket, go up in the air, hit a maximum point, and then come back down. They want to know when the toy rocket lands. So which of the other types of forms of a quadratic equation, which one will we be using? We're in standard. Do we want to go to factored or vertex form? What will vertex tell us? That'll tell us the highest point. Right? That'll tell us the maximum. We want to know when the toy rocket's going to land. So what will we be using? Right. We want factored form. Factored form will let us find our roots or our x-intercepts. Okay? So we're going to be going from standard form to factored form. That's our goal. Now there's definitely several types of factoring. Factoring by product, decomposition. We don't really use algebra tiles too much, but I have shown it to you before. We'll do factoring by product. That's our one that we normally use, okay? Now, first off, because our A is negative, whenever we do factoring, what's our very first step? Greatest common factor. You know what? We should put that in our types of factor. Okay, so in terms of a greatest common factor, what is the greatest common factor of the three terms in this trinomial? All right, so we're going to be dividing each of these three terms by -1. So that means the -1 now becomes the common number on the outside. And inside the brackets, we divide each of these terms by -1 to figure out what will be inside the bracket. So negative x squared divided by -1. So, again, we're going to factored form, so we're not completing the square like the other day. So we've taken our greatest common factor out. Negative x squared divided by -1 is x squared. Positive 5x divided by -1 is negative 5x. And 84 divided by -1 is negative 84. Now we're going to do our factoring by product. We're going to factor the trinomial here inside the brackets. We'll write the factors of our first term. So factors of x squared are 1x and 1x. And factors of 84, we're probably going to have a couple here. So 84 is obviously going to be 84 and 1. 2 and 20, no, sorry, 42. 3 goes in how many times here? That's going to go in 28 times. Is it 28? Okay. 4 goes in 21. We're going to have to make some room here. So I'm going to move my factors over for our columns. 6 goes in 14. Good. 6 goes in 14 times. 5, no. 6, yeah. 7, 12. 8 doesn't go in. And 9 doesn't go in. It either is 10 or 11. Okay. So we have our factors here. Now, we know our first term. We're going to try to go through this a little quicker using some logic, okay? We know these are going to be the first terms in our bracket. So I can already start it out. I'll put my greatest common factor, -1. Bring that down. And we're going into factored form. Remember, factored form has x minus r, x minus s. We know we're going to have an x and an x. They're the only first terms possible. We're going to have to multiply to get to -5. So right away, I'm going to be using terms that are going to be close together. So we're definitely not going to be using probably these first 3. Let's take a look. 6 of 14, what kind of difference is that? 8. It's not really going to work. What about 7 and 12? That's a logical one, okay? So we know that we're going to have to multiply the products, and they're going to have to add together to get our middle term, which is -5x. And it looks like we're going to use 7 and 12. So 1 times 7 is 7x, and 1 times 12, sorry, 1x times 12 is 12x. In order to get -5, what does one of these terms have to be? Negative. And in fact, the 12 will need to be negative in order to add them together and get -5. So because the 12 is negative, the number in the column I multiplied by becomes negative. And we just got to double check. Positive 7 times -12, does it give us -84? Yeah, we know that those signs are right. Because the first terms are the same, it doesn't really matter if they go into opposite brackets because our first terms are going to be the same. But normally, whatever we multiply by, we have to put into an opposite bracket of the first term. So in this case, we're going to put -12 in one of them and positive 7 in the other. Not in this case. Other cases it does. Now, I'm in factored form. That's very nice and all. But what do I have to do with this factored form now? Let's compare to our factored form. There we go. So we're in our factored form, but we're not quite done. I need to find when it's going to hit the ground, when this toy rocket's going to land. So in other words, I'm looking for an x-intercept. And we know that our x-intercepts, no matter what they are, our y value will be what when we're on an x-intercept? 0. Our y is going to be 0. So what we're going to do is in this equation, we're going to plug in for y, which is here. We're going to plug in the value of 0 and then solve for our 2 x variables. So underneath, we have 0 is equal to -1, x minus 12, x plus 7. I need to isolate these variables. So I got to get rid of that -1. How do I get rid of it? I'm going to divide both sides by -1. What does the left side become? 0. 0 divided by -1 is still 0. And the 2 -1s on this side cancel out. So I'm left with x minus 12, x plus 7. Okay. Now, because these are multiplied by each other, we know that in order to get 0, one of them is going to have to be 0. So we're going to test it for both of them. This is where we split our equation into 2 equations. So we set each of them equal to 0. 0 is equal to x minus 12, and 0 is equal to x plus 7. When we bring the 12 over, we get x is equal to 12, and x is equal to -7. So our 2 x-intercepts are 12 and 0, and -7 and 0. If we fired the rocket, let's make sure we know. So one very important thing we should have mentioned at the beginning are, what are our 2 variables? Our y was the height of the rocket. So y represented height. And x represented distance in meters. Okay, so distance in meters. So we want to know when the rocket is going to land. Since our height is 0, we know these are the 2 times it would hit the ground. Which of these 2 makes more sense than the other one? Going backward 7 meters or forward 12 meters? It's right, because we're firing a rocket, you could always fire it backwards, right? But in that case, this question is modeling something that we assume the way this is working, that anytime you fire it, no matter what direction, it's going forwards, okay? Because if I face the other way, it's still forwards to me. Do you guys understand that idea? Okay. So we're looking at our positive 12. So it looks like the rocket's going to be 12 meters away from its starting point, okay? So we're looking at 12 meters away is when the toy rocket is going to hit the ground. So let's just quickly make sense of this one more time. Why is our height? We're looking for when the height's 0, so this is 2 points. We assume whenever we fire the rocket, maybe we were standing up on a ledge or something when we fired the rocket. We don't quite know yet. We fired the rocket and it went 12 meters. Okay? X is representing the horizontal distance from where we fired this rocket. Okay? So, with that being the case, what if I wanted to figure out how high the rocket was when I fired it? What would I be looking for? I would look for the y-intercept. It looks like we're going to have, this would be a better sketch, something that's going to be like this in terms of our rocket. So is that a certain point? Okay, second example. Now we're going to use the exact same equation. We're going to use the exact same example. This time, we're going to find out how far horizontally this rocket has gone, okay? So we've already solved this part. I know I've written a stone. Let's say it's the toy rocket again. Sorry. It's our toy rocket from the original question. Toy rocket goes into a ravine we discovered, okay? So it turns out that this toy rocket was probably high up off the ground, which we assumed it was before, right? From what we were trying to solve. So in other words, we'll probably have something that looks relatively like this. Here was our toy rocket. The ravine was down here, okay? And the rocket started up here and went down into the ravine. We know that our x-intercepts, where did the toy rocket hit the ground? 12 meters away. Okay. We already figured that out. We already know that it was 12 meters away from where it was shot. This time I want to know, how high up was the toy rocket when it started? Okay? Now, there are 2 ways we could have figured that out. We can use our factored form, and our factored form we're going to be looking for what if we're looking for where the rocket started? What is this? Y-intercept. We know this is our y and x-axis. So we'll be looking for a y-intercept. So we can use either our factored form or our standard form to solve it. One of them is going to be much faster. We're going to figure it out right now. So one option is our factored form. One option is our standard form. It's actually the exact same equation. Okay? In our factored form, we had y was equal to -1, x minus 12, x plus 7. Our standard form was y was equal to -x squared plus 5x plus 84. Now, in order to find a y-intercept, what is one of the coordinates going to be? X will be 0 in that case, right? If we're looking for a y-intercept, that is when x is at 0 at this point. So we're going to plug the number 0 in for the x's in the equation. So in each of these equations, we're going to plug 0 in for x and solve it. finding a y-intercept. So we'll do factored form first. Y is equal to negative 1, 0 minus 12, 0 plus 7. Negative 1 times negative 12 times positive 7 is going to give us positive, I'm going to tell you right now, it's 84. Now, in our standard form, same idea. Y is equal to negative 0 squared plus 5 times 0 plus 84. 0 squared is 0 times negative 1 is 0. 5 times 0 is 0 plus 84. Our y-intercept is 84. There's a very fast way to find a y-intercept if we have standard form. If we have standard form, our constant is going to be our y-intercept. Okay? So, because we know that when we plug 0 in for either x, the other two terms will just cancel out and become 0. We'll be adding 0 plus whatever the constant is. So in standard form, our c is going to represent our y-intercept. It's a fast way to find a y-intercept is in standard form. It's the fastest way to find it. Just like the fastest way to find roots is in factored form, and the fastest way to find the vertex is in vertex form. So what this means is our rock, or our toy rocket, sorry, was 84 meters above the ravine when it was first fired. Okay? Yeah, basically went straight down. But it went 12 meters horizontally, and it dropped down another 84 from where it started. Okay? All right, example number 3. Example number 3, they've given us a rectangle. The dimensions of the rectangle are a length of 3x plus 1 and a width of 2x minus 5. The entire area of the rectangle is 1,150 centimeters squared. So they've given us quite a bit of information. Let's try to piece this together. We do know that area of a triangle, rectangle. Area of a rectangle is our length times our width. Okay? Something we are supposed to already know. Now, what we're going to do is we're going to plug in the values they've given us for length and width into the length and width in that equation. So we get area is equal to 3x plus 1 times 2x minus 5. We have that. We also have the area of this triangle. The area of this triangle is equal to 1,150. Why do I keep saying that? Rectangle. I'm going to write it at the top. Maybe it'll help me remember. So, we've plugged in our information. We've replaced area in the equation with 1,150, and we've replaced the length and width with the measurements they've given us. I'm going to move this down a little. So I'm going to rewrite it down here so we have some room now. We have 1,150 equals 3x plus 1, 2x minus 5. Now, this may look like our factored form. In fact, it is very similar to what factored form looks like. Problem is, if we want to find out what our x's are, we're going to want to expand, simplify, go back to factored form. We'll need to FOIL. That's right. Now, all right, so we are going to need to expand and simplify, in other words, FOIL this equation. We want to turn it into a proper standard form. Standard form is set equal to 0. So I'm going to FOIL the right side of the equation. So 3x times 2x gives us 6x squared. Those are our first terms. Our outside terms are 3x times negative 5 gives us negative 5x. Our inside terms are 1 times 2x, which gives us 2x, 15x. And finally, our last terms are 1 times negative 5, which are negative 5. No, everything's right there. So, I'm going to simplify our terms, and I'm going to drop the brackets. I have 6x squared. 15x plus 2x is negative 13x minus 5. And in standard form, we want to be set equal to 0, so I'm going to move the 1,150 to the other side of the equation. We're going to end up with 0 is equal to 6x squared minus 13x minus 5, subtract 1,150. Finally, our standard form is 0 equals 6x squared minus 13x minus 1,150. Okay. Now we are in what we referred to before as our standard form. And the reason we want to set this equal to 0 is so that we can eventually factor it. And when we have the factors and it's set equal to 0, we know one of them will have to be 0. So I know we looked here, and we know that these two factors together are going to equal that. But there are many different numbers that can equal 1,150. There are a ton of options. So I don't know what to set each bracket equal to. When we're set equal to 0, we know that the only option to get 0 is if one of them is equal to 0. And I'm going to explain that a little more. So we have our form here. We're going to want to factor this. Okay. In fact, we could do this one by decomposition or product form. Which would you guys like? So what we're going to do next is we're going to be turning this into factored form. So we have 6x squared minus 13x minus 1,155. We put our factors of 6, which are going to be 1x, 6x, and 2x times 3x. Our factors of 1,155, we're going to have quite a few. Obviously 1. 2 will not go in. 3 will. We can estimate what they'll be. It's best if we always put as many options as possible. 3 is going to go into this how many times? 385 times. 3 goes in, 385. It's nice to have a calculator so we can test it out. It doesn't go evenly. We know 5 will. 231. Will 6 go in? No. 7? Does it? 165. Does 8 go in? Oh, yes. Good point. And rules of 9, I think, is if 2, 3, and 6 go in. So this doesn't work for 9. Now, the problem is we're going to end up with quite a few options here. 11 is what? 11 goes in 105. What we're going to do, we're going to pause this and put them all in. Okay, so we went through this. There were quite a few factors we've discovered. These are going to be the first terms in our bracket. And one of these is going to be our second term. Now, one way to tell that you're done with your factors is once you get two numbers close together. So once we got to 33, then we tested 34. Once we go into 35, we've already tested 35 and up. Once there's a turnover, we know we've found all the factors at that turnover point, okay? So we have quite a few here. And we're going to go through trial and error. I'm going to save you guys a little heartache, but it is something you may need to do. We're going to be looking for these, okay? And we're going to test that out. They need to add, so let's give ourselves a little room. We know the products need to eventually add up to negative 13x. We're going to actually end up multiplying 6 by the 15, I think. 6 by 15 is going to give us 90. And 1 by 77, perfect, gives us 77. Okay. We know the 90 is going to have to be the negative 1. So what did I multiply to get the 90? What number? The 15. So that means the 15 will have to be negative. And we can double check, does negative 15 times positive 77 equal negative 1155? Yes, it does. So here's the tricky part. When we go to put it in our factored form, we know we're going to get 0. And we're going to place our first terms in first. We're going to get x and 6x. Now, this is where it's important what bracket they go into. Because I multiplied 6x times negative 15, the 6x has to go in the opposite bracket of the negative 15. Same idea with the 1 and the 77. The x and the positive 77 go in opposite brackets. Okay. So now what we've done is we have a factored form. And this is what I was talking about earlier. We're multiplying these two numbers. To get 0, we know one of them has to be 0. So we're going to test it as both of them. Whereas before, we had something that looked like factored form, but it wasn't set equal to 0. And because it wasn't set equal to 0, there are many different solutions to what these could be. There are so many different numbers that can multiply to that. But in the case of 0, we only have 2 options. This is how we narrow down our options and solve the question faster. Okay? So we've now done that. I'm going to move it to another page. Okay, so I've just moved to a new page so I have some room. I know we've done quite a bit. Recall, what we're trying to do is find the distance of the sides of this rectangle. So we now are set up in our factored form, and we know we're set equal to 0. We need to split our equation and set both of these brackets equal to 0. We have 0 is equal to x minus 15, and 0 is equal to 6x plus 77. We're going to isolate for our x's. When I bring 15 over, I get 15 is equal to x. When I bring 77 over, I get negative 77 is equal to 6x. And then I would divide both sides by x is equal to x, or negative 12.8. Let's prove that over here. 77 divided by 6, negative 12.8. So, we have our options. We have 2 answers. We have 15, and we have negative 77 over 6, or negative 12.8. So, what we're going to do is we're going to test both of them. Maybe there are 2 options. It's most likely there's only one. I'm going to test the negative one first. It's pretty unlikely that it'll be negative sides, but we don't know. Let's put them into the equations. I'm going to put it into my length to start. So my length is equal to 3 times x plus 1. Negative 12.8 is going to be our x value. So we're going to plug that in for x and test it. 3 times negative 12.8 plus 1. 3 times that plus 1. Is it possible to have a length of a rectangle that is a negative number? Does not make sense. It's an impossibility. It's an imploding rectangle? No. We don't have a negative distance with a rectangle. So in other words, what this is telling us is our negative answer is illogical. It doesn't make sense. So the answer we're looking for is when x is 15. And when x is 15, we can now solve our length and our width. Length is equal to 3x plus 1. We're going to plug 15 in for x. So 3 times 15 plus 1 gives us 46. Our other option is our width is 2x minus 5. 2 times 15 minus 5 is going to give us 25. Okay? So according to our discovery, we have a rectangle that has a length of 46 centimeters and a width of 25. We got to make sure this fits our area, which we knew before. Remember, our area was equal to 1150. So let's figure this out. Does 1150 equal 46 times 25? 46 times 25? 1150. 1150. So this works out. We've now solved question 3.